Hi guys, this is the second part of chapter 20. So we're still talking about solutions, but today we're going to talk about things that affect the solubility, like how can you speed it up? How do those conditions actually change the things that are happening to form the solution? And then we're going to talk about how to speed it all up. So first things first, temperature. We have talked quite a bit about temperature. You know that temperature is the measure of the movement of particles. So if we're talking about solutions, if we take the temperature and we heat up the solvents or even the solute, then that will increase the solubility. And this happens for two reasons. First of all, the increased temperature will weaken the structure of the solute, like basically make it, make the bonds that are holding the pieces together, make them weaker so that they are easy to separate. And then also, that temperature is causing the solvents to move more quickly. That means they spread out a little bit, which means basically there is space for the particles of the solute and the solvent to kind of mesh together. So everything kind of spreads out and then the holes get filled in when that solution is made. Now that is if you are talking about either a solid and liquid solution, or even a liquid and liquid solution. Temperature within those cases will increase the solubility. Now, if you're talking about gases, it's the opposite. And because of the way that gases are, increasing their temperature actually makes them less soluble. And the reason that this is the case is because gases are already moving really fast, way faster than solids or liquids. And so to get them to dissolve into another substance, you have to slow them way down. And so, excuse me, if you're speeding them up, all you are doing is giving them enough energy to escape from the liquid. When they package, or bottle like Cokes, it is always under very, very cold conditions that they will inject that carbon dioxide into the liquid to slow it down enough to give them time to put the cap on the bottle, basically. And that's the reason why if you have a hot Coke, like if you left a bottle of Coke in your car on a hot day, if you got back, it may not have actually exploded, hopefully all over your car, but if you were to open it at that point, it would probably, everything would fizz out because you've given all of those gas molecules enough energy and they are ready to get out. Another thing that you may have heard is that fish are more active, like in the morning or when the temperatures are cooler. This is because fish need oxygen. That oxygen is a gas that is dissolved into the water that they are swimming in. That's what they're breathing in. And when it's cooler, there's more oxygen in the water, which means they can breathe more basically, and they're going to move around more. Hot days, fish slow way down. They're conserving their breathing rate basically because there's not as much oxygen in there. So any of you fishermen may have heard that. All right, now another factor or condition that will affect the solubility of a substance is pressure. Now this one only applies to gases. And this high pressure is something that you can put basically on top of the solution and have it kind of act as a cap. And so if you have high pressure above the solution, then you will have a higher solubility for your gas. And there's actually a law for this. It's called Henry's law, and it says that the greater the pressure on a liquid, the greater the mass of the gas that will remain dissolved. Again, if you think about Cokes, when you have an unopened Coke, like you just bought it, when you first unscrew the cap, there is that kind of fizzing noise, that hissing noise when all of the pressure is released. That pressure that is being released is put in there when the Coke is first bottled to act basically as an extra lid on top of the solution. It's just more gas basically on top of there. As soon as you take that extra lid off, as soon as that pressure is released, the gas that is in the liquid will immediately start to come to the top, and most of it will escape in that very first time that you open your Coke. So if you have a bottle of Coke around that you haven't opened yet and it has like the clear plastic bottles, watch it, look at it when you're opening it next time, and you will see all of those gases, the bubbles, try and rise to the top. And so every time after that you open the lid, there will be a little bit of pressure that will come out, depending on how many times you're opening it, because those gases are filling in that space. But it's also why, like, if you just have a Coke in a glass and you let it set out long enough, it goes flat. There's not pressure on top of that solution anymore to hold it in place. Okay, now saturation. Saturation is basically how much of a solute has been dissolved into the solution. And depending on the temperature, you can have kind of different levels of saturation. You can have different amounts of solute that will dissolve. Now, when you are making a solution and you are, say it's a liquid solution, so you have water and you're like dumping salt into it, the limit is reached basically when that salt starts to settle onto the bottom of the container. So you're dumping salt in, kind of stir, give it a minute to dissolve. Eventually you will reach a point where the salt will start to settle to the bottom, and nothing that you do will help it become dissolved. At that point, the solution itself, so everything above the settled solute, is considered saturated. And so at that point, it is holding as much as it possibly can. The liquid is holding as much salt as it possibly can be holding. That is saturated. The solute that settles out is called a precipitate. Just so you know, I think it's one of your vocab words. This term, saturated, is used, sometimes you'll hear, like in the spring in particular, when we have a lot of rain. They'll talk about how, okay, the ground is saturated now, and that's when you start to see floods and those kinds of things. The ground is holding as much water as it can. So same thing with a solution. The liquid or the solvent is holding as much solute as it can. Now, you can have unsaturated solution. This is one where it contains less solute than it could dissolve. So this, if you're doing water dissolved or salt being dissolved into water, if you just put, like 1 spoonful of salt into a glass of water, it's unsaturated because you could add more salt and get more of it to dissolve. And then the last one, a supersaturated solution, has a lot more to do with actual temperature. And so it is defined as a solution that contains more solute than it should at a certain temperature. And these are ones that you actually have to make. You have to heat them up and cool them down and do all kinds of things. But what you do is you take your glass of water and you take all of your salt and you heat up the water, and then you dump in a lot of salt. So you just continue to put in and continue to heat until you get it all dissolved. Then you're not done yet, because then to actually make it super saturated, you let it cool back down to room temperature, or whatever the temperature is that you're looking at. You guys may have done this in science before. I think you may have done it last year actually, where you made like little crystal structures, like with borax or Epsom salts. Same thing, you dissolve way more salt than you could in that water because you've heated it up so much, and then you let it cool back down. The crystallization part happens pretty often with supersaturated solutions, just because there's so much solid, or salt in the case of the Epsom salts, that it comes back out of solution and will form these really cool crystals. Also, just so you know, if you're a fan of rock candy is considered a supersaturated solution. They do the exact same thing. Water with a whole lot of sugar. Like, you would be amazed at how much sugar you can actually dissolve in hot water. And then they let it crystallize, and they, and then they let it cool back down. And then they will put like a stick or something in there, and the sugar will all start to stick to the stick. And you have those really cool shapes that are the rock candy. Okay, last thing. So factors that affect the rate of solution. So how quickly can I get this solute to dissolve? And I always tell my kids when they're doing this or thinking about this, to think about making a cup of hot chocolate. Oh, I have it written down there all too. So hot chocolate. All right, so you probably do all three of these things if you've ever made yourself some hot chocolate with the powder. First of all, you heat up your solvent. So your solvent in this case would be water, or if you want to be super fancy, you could use milk for your hot chocolate. And so you heat it up first of all, and that causes those solvent particles to start to move faster. So they are moving quickly. Then you dump in your hot chocolate, your powder, and that's the solute, and you stir it. So that stirring just brings the solute molecules in more contact with more of the solute particles. So it spreads the milk out into the chocolate particles and vice versa. And so they kind of intermesh, you know, like we talked about before, so they kind of mesh together. And so that gives the molecules of the milk or the water a little bit more time to kind of pull apart the chocolate. And then if you're like me, and this happens every time, I don't know why, right in the middle of my stirring of my cup of hot chocolate, there's that little kind of whirlpool, and you get those bigger chunks basically of your hot chocolate mix. And so I personally always will take my spoon and I crush them up against the side of the cup. And what that does is it increases the surface area of those chocolate particles, and then just gives the milk more area to get around it. It's one of those things like, you know, what's going to dissolve faster? Grains of sugar, for example, or a sugar cube. It's always going to be the grains, because the smaller the particles, the faster they're going to dissolve. And so that's the crushing or grinding up of the solute. So think about making hot chocolate on that, and that is what affects the rate of the solution. All right, thanks guys. Have a happy Easter. I think you should get this on Thursday right before Good Friday. So enjoy your Easter weekend. Bye.